Right. Exercise in chapter number 4 and chapter number 5. Let's discuss them first, and let's move to the next section after that. And so here, these are the exercises given in chapter number 4. For the following questions, select correct answer or the most suitable answer from the responses given. Which of the following response contain only matter? So air, water, light, water, heat, and breath. Electricity, brick, ink, and air. So only matter.
A brick, ink, and air.
Yes, brick, ink, and air. So brick is a solid, ink is liquid, and air is, so it is gas. A property only, so other things like you can see electricity, heat, light, these are energy sources, right? So that's why answer 4 is correct. A property only common to solids and liquids is, so what is the property common to solids and liquids?
Having a definite volume.
Having a definite volume, right? Having a definite shape. Actually, shape is not definite because like solids have definite shape, but the liquid will take the shape of the container, the containing area. Ability to compress is harder to compress. Actually, both are harder to compress. Having definite volume, yes. A free movement of particles, no. It's like in solids, you cannot see any free movement of particles, right? Therefore, having definite volume is the correct answer. When a drop of ink is added to a vessel of water, the color of ink spreads throughout water. Which of the following response explain this observation best? Right. So when you add a drop of ink to a water bottle or water vessel, so it spreads. So what is the feature? What is the property? The property is?
Water is discontinuous.
Yes, water is discontinuous. Like it's created with, so, elements, and these elements, these are having gaps. There are gaps between these, and so that is the discontinuous nature, because like you can break it down to small elements, H2O. So that is the feature is called discontinuousness, right? So which of the following is a pure substance? Pure substance.
No idea.
So can you remember the pure substance and non-pure substances we discussed? Like if anything is created with, so we discuss elements, right? So I think we have discussed it here. Purity and non-purity here. Substances, you can see. So these are pure substances. Gold. When you break down the basic element, the smallest elements is also gold. Mercury, when you break down, the smallest is also mercury. So when you break down, the smallest is also the same substance. We call that a pure substance, right? Here, so pure substance and non-pure substance. So here you can see. So if this is the no, so we have the definition, not here. So let's say discuss the purity. Okay, here, right? So please see, right, when you further break this down, consider the cylinder containing nitrogen gas and cylinder contain ordinary air. The nitrogen gas contain only nitrogen gas, but that means if you break this down into the basic element that which it is created, so you can see it's nitrogen gas. The cylinder of air, in other hand, it has several gases like nitrogen, oxygen, carbon dioxide. A lot of gases are mixed, and all these gases are there in that. So we call that is a non-pure, right? Non-pure. But so here, let's think about water. So let's think about let's think about water in a well, or water in a river, or water in saline water in marine environment, ocean. So these are non-pure. Why? Because it's not just water. There are some gases and there are some salt dissolved in it. So we cannot call that a pure. We cannot call that pure water. But so distilled water or pure water. So when it comes to this, like distilled or pure water, it is only water. So it can be called pure substance. So anyway, any pure substance will have a fix. So how we can identify a pure substance? Because the melting point, boiling point, these are fixed. So when it is non-pure, these are changing. Okay, here you are given some examples. Please, like since you cannot remember that, that's why I'm revising. So you can see pure water is only having water, so it's only one component. But air having many components. Drinking water can have many components. Sugar is only having sugar, but salt solution will have salt and water both. So piece of copper will have copper only, but tea will have different components. Aluminium will have aluminium only, iron will have iron only. Silver will have, the silver will get silver. It will have silver only. So these are pure substances, right? Okay. Now please answer the question. I'm going back to the question. Here we are. Right. So which of the following is a pure substance?
Bottled water.
Bottled water is a drinking water, right? It may have several minerals. It's not clear pure water, right? It's bottled water can have different elements, even some gases dissolved in it, because it's not pure, right?
Okay.
Then what? So what about crystals of sodium hydroxide? When you further break down, still you can find sodium hydroxide, right? Isn't that so? Crystals of sodium hydroxide is a solution. So, but this is not this is not this is not sodium hydroxide solution. They're asking about sodium hydroxide crystals. When you further break down these crystals, you can still find sodium hydroxide. So you can call this is a pure substance. Sodium hydroxide is a pure substance. Right? Salt water is not pure. Why? Salt and water both are there. But if you take salt or sodium chloride only, it's a pure substance. Right? Please understand, compound substances are also, so H2O. H2O is water. Water has two hydrogen and one oxygen, and H2O. But still, pure water, you can call it pure substance because the basic element, it is water, right? ඒක හැදිලා තියෙන මූලික අණුව ජල අණුව. ඒක අපි ආයෙත් බෙදලා පරමාණු වලට බෙදලා මේක පියෝ නැහැ කියන්නේ නැහැ. අණුව මට්ටමින් අණුවක මට්ටමින් ගත්තොත්, if you take that component, so if it is similar to the whole thing, we call that a pure substance. Right? එතකොට bottled water වල තියෙන ප්‍රශ්නේ තමයි bottled water වලට තියෙන්න පුළුවන් තව එක එක gases දිය වෙලා තියෙන්න පුළුවන්. කොහොමත් minerals තියෙනවා. පොඩ්ඩක් බලන්න ඔය label එකේ ගහලා තියෙනවා. There are some minerals in bottled water. Sometimes even for cleaning purpose they are putting some chemicals. These are not damageable, but there are some. It's not pure. Fizzy drinks anyway, so it has like it's a mixture, no? Then colorless toothpaste. It's a mixture, right? You have a lot of components in the toothpaste, but when you take this one, sodium hydroxide crystals, so when you break it down, still the sodium hydroxide is the basic element. Therefore, the fourth one is the answer. Okay, fifth one and sixth one. Property of trembling upon the application of small force is called property of trembling upon the application of small force is called
Brittleness.
examples. Can you give me a few examples having brittleness? Your answer is correct. Your answer is correct. So can you give me one example for that?
Gadol.
You can take that bricks. And glass. Why can't you take glass? The glass lazy again, me cadilla bindilana chuti velta punchi force එකක් දුන්නා දැන් gadol වලට නම් ටිකක් ලොකු force එකක් දෙන්න පොඩි force එකක් හරි කමක් නෑ හැබැයි glass වගේ දෙයක් ගත්තා so very good example right බංගුරතාවය නේද බින්දෙන් සිංහලෙන් කියන්නේ ඒකද බංගුරතාවය කියලා brittleness so I cannot remember the exact term but brittleness is anyway so it will crumble it will just break into the small pieces when a force provided it's external force provided. Okay, 6. Given below are three ideas expressed by three students about the masses of equal volume of water and kerosene. Right, masses of equal volumes of water and kerosene. Their masses are equal. Mass of kerosene is less. Mass of water is greater. So what do you think?
Mass of kerosene is less.
Because equal amount is taken, mass of kerosene is less. So how can you tell that? When you put them together, what will happen? Kerosene and water, when you put them together, what will happen? Which will float?
Kerosene.
Kerosene will float. Mass of kerosene is less is correct. Mass of water is greater is also correct, right? So B and C both are correct.
Okay.
Which of the following substance is an electrical conductor?
Iron.
Definitely. Iron is electrical conductor. What is the boiling point of pure water stands atmosphere pressure? Boiling point of pure water is
0 Celsius.
Oh, boiling. It's not melting. Boiling.
No.
Boiling means like when the liquid become gas.
Yes. 100 Celsius.
Yeah, 100 Celsius. What is the liquid metal that conducts electricity?
Water.
Water. Yes, a liquid metal. Liquid metal. So they're asking liquid metal.
Mercury.
Not just liquid, yeah, mercury. Mercury is a liquid metal. Correct. Prasadiya. You can tell me, viduli yana metal ekak niyahane. Mata ek dekke naya. Liquid kine kutai. So liquid metal. Some ideas are expressed by students about boiling point of a liquid are as follows. It is the temperature at which change in state occurs. That is correct, no? It is the temperature which a change in state occurs. That is boiling point, right? Boiling point of a liquid. It is the temperature at which solid turns into liquid without changing the temperature upon heating. Boiling point of liquid. Solid turns into liquid, no. It's not solid turn into liquid, then what turns into? So what is the transformation happen here?
Liquid into gas.
Liquid into gas. It is the temperature at which turns the liquid turns into gas without changing the temperature on heating. Yes, that is correct. A is the correct answer. And the temperature will change in status occurs, correct? And this is the state change. So fourth one is the answer here. Question number 11. Which of the following is correct about the density of a metal?
It takes a definite value.
density of a metal, it always take high value, no. Mostly it takes low value. Cannot say it like that. Density of a metal. It takes definite value, yes, because density is definite. So if you take if you take equal amount of solid, you can say the weight of that, the mass of that when we taken. So that is definite value, yes. Densities of all metals are equal? No, it's not. Densities of all metals are not equal. So these are different. All different metals will take different densities, right? So definite value, yes, that is third one is correct. So place the mark right of each of the following statement correct. If wrong, you have to mark as wrong. Air does not belong to category of matter.
Wrong.
Air does not. No, it's wrong. All matter has particulate arrangement. Correct. It's particles. Gas particles move freely. Correct. Sun contains only energy.
Wrong.
No, it has matter as well. It's wrong. Solid, liquid, and gases can be compressed easily.
Wrong.
Wrong. Only gas can be compressed easily. A liquid has a fixed shape as well as a fixed volume.
Wrong.
Liquid has a fixed shape. No. Fixed volume is correct. Fixed shape is wrong. Copper is a brittle metal. Copper is a brittle metal. Is it brittle? No, it's not. Then sulfur is electrical conductor and a non-metal.
Wrong.
Then sonority is a property seen in most of the metal.
Correct.
What is sonority? Nothing of the sonority again. Yes. Sonority.
Lasting sound.
Yeah, it's lasting sound will be there. So, all metals have malleable and ductile properties. All metals have malleable and ductile properties. Is it? All metals? Hamegama malleable, the ductile. Is it correct? No idea. So no. So just take this mercury. Mercury is a metal. Is it malleable, ductile? Cannot tell like this, right? So all metals are not malleable. So maybe at some temperature it can take, but not always. All metals are malleable and ductile properties, not always. Right? Okay. So these are some like terminologies that we have used. So you can see sonority here. Right? Ductility is harnyatave. Then so malleability is ahanyatave kenamukad. So what is malleability? Ductility and malleability, can you remember? So we discussed this in earlier grades also. Ductility, malleability. Please explain. Just see the book and see. Say what the balalahari kiyan chutta. Ductility, malleability.
Ability to be drawn into a wire without breaking.
That is what?
Ductility.
Then malleability.
Ability to be harmed into sheets without.
Yeah. Sheets hadanna puluwan. Thalala sheets hadanna puluwan එකක්. අනිත් එක මේ තලලා හෝ ඇදලා wire හදන්න පුළුවන්. හරි. ඔය දෙක තමයි. දැන් ඔය හැම දෙකම කරන්න පුළුවන් හැම එකටම. Not for all the metals, right? Some metals are even brittle. Some metals බින්දෙන සුළුයි. ඒ හැම metal එකක්ම එහෙම ඇදලා කම්බි හදන්න හරි එහෙම නැත්නම් තලලා තහඩු හදන්න හරි එහෙම කරන්න. Okay. Then the sound lesson, we have just discussed about this lesson, and we were like here, yes, we discussed this part, just everything. Noises, yes, we discussed, and yeah, we have done this. Now there are questions to be answered. In the chapter number 5 also, there are some questions to be answered. Let's answer that questions now, right? Okay, can you do the first one? First one, I'll give you time. Try to do the first one quickly and tell me the answers. Send me the answers into chat, please. Send me the answers into chat. Right, so let's discuss the answers. Sound of high frequency can be obtained when the wires of violin are, yes, shorter. Yes, when wires of the violin are shorter, high frequencies can be obtained. So, you know, when playing the violins, so you need to move the finger to the, like, closer to your neck, because to make it shorter, when you make it shorter, what will happen? The frequencies will be high. You can play high tones. Sound of the high frequency can be obtained when the membrane of the drum is thinner or thicker. So when it is thinner, yes, high frequencies when it is thinner. When thin membrane is there, the frequency will be high. Human ear is to any range of sound, not sensitive. Yes, it's not sensitive, correct. Vibration of an object are regular, irregular. When musical tones are, it's regular, right? When musical tones are there, the vibrations are regular. You can reproduce that. It is a regular vibration. If it is irregular, mostly it is voice, noise. These things are irregular. Categorize the musical instrument given into 3 groups according to the, okay, this you have done already, right? So this you have done already, therefore I'm not going to spend time. This is the homework that you have done. So, okay, then again you have to put right and wrong in front of the statements given below. That is question number 3. With that, the chapter is done. Can you try to answer these questions very soon? So you have to put right or wrong in front of this statement. When, so why this 4, 5, 6? Is there 1, 2, 3, 4? So I think there is a number in error, right? Anyway, so I cannot see any. Okay, when wires of a violin are tightly stretched, it gives low tone. So what do you think? Will it give a low tone or high tone? Tightly stretched, it gives high tone, right? If it is tightly stretched, it gives high tone. So when the length of vibrating air column is less, it gives sound of low frequency. When the air column is, so when air column is shorter or less, it gives high frequency, right? Xylophone is an instrument that produces sound by vibrating bars. Yes, that is correct. Some mental depressions, conditions of the patient can be cured by musical therapy. Yes, it's also correct. We discuss about brain waves. It's also correct. Okay, your answers are correct. Okay, so we are to start our new lesson, and I'll briefly introduce this. So now we are in the 6th lesson of our book, and actually, so there's another part. This is just, you know, part 1. So there's another part of this. Therefore, we need to quickly finish this and move to the second part. May I know in your school, so what is the extent that you have completed? Have you completed this 6th chapter? 6th chapter, have you completed or still doing? So what is the chapter that you are doing in your school?
No, sir. Not yet.
Then which chapter? Is it 4 or
We do
key chapter?
fourth chapter.
Fourth. So when your term is going to be finished, is it in December or March?
Fourth one.
December the March the term not sure. Right, December the December the term. So I think so. I'm not sure so what they are going to do with this schools this time. Probably they have to finish by December, right? Then so there is a big part to anyway. So I think our speed is okay. So we can speed up further, right? We can speed up further, but so first of all, the first part we have to do it slowly because we have to understand these lessons very well, right? Okay. So magnets. So magnets are kind of like very important components which is used in our day-to-day life, right? So because like we need magnets, so you know the motors are depending on magnets, and there are a lot of components like electricity can be produced using magnets. And when there is a electricity conducting materials, there is a magnetic field. And also in the planet Earth, there is a magnetic core, right? How the solar system exists. So there is a magnetic bond, right? Electromagnetic interference, electromagnetic bonds, not electromagnetic bond, but there is a magnetic bond between these planets. So everywhere the magnetism is there. The static magnetism or static voltages can be dynamic magnetism, or it can be electromagnets. So can be permanent magnets, can be anything, right? So here, so activity number 1. So it is like using the permanent magnet. Permanent magnet means it is not magnetized in time to time. The electromagnet is not a permanent magnet. When electricity is provided, the electromagnet will. I think you can remember. So we have done a practical in lower grades. So where copper wire is like wrapped around a nail, and then you have given power, right? I think you can remember that practical. Copper wire and nail. So this is simple electromagnet that you have created. So if you cannot remember that, please you can create this. This is a very small exercise. So what you can do is this. You can use a battery and you can wrap. So you need only these components, right? So iron nail and a copper wire. So you can see, so this iron nail is wrapped. So using this copper wire, it's wrapped. And then voltage or power is given. When power is provided to this iron nail, what will happen? It will attract these magnet sensible objects, maybe nails, clips, keys. These can be attracted by this. But when power is disconnected, it will be detached. When power is connected, it will be attached, but when power disconnected, it will be detached. This is very simple electromagnet that you can create in your home, right? Using small things, small set of elements. So please do that. And so in a permanent magnet is not like that. So permanent magnets providing magnetism always, regardless of, so whether it's given power or not, it will produce, right? So piece of thread and a stand, various type of coins, and iron nail, brass nail, a pebble, plastic ruler, and several other things that you can test the magnetic properties. So you are given all these things in the activity number 1. Hang the magnet using the piece of thread as shown, and bring each substance one at a time close to the magnet. When the magnet remains still, enter the observations, right? So you have to check the magnetisms of these materials. Some coins I have seen, some coins are like attaching to these magnets, but some are not having the magnetic properties. Anyway, what you have to do is you have to make this table using small thread එකකින් මේක නූලකින් චුට්ටක් එල්ලලා මේක balance කරගන්න ඕන. When you balance, you can find the magnetic north and magnetic south too. චුම්බක උතුර චුම්බක දකුණ ඒකත් හොයාගන්න පුළුවන්. මොකද මේ magnet එක stable වෙන්නේ මුකුත් ගාවල නැතිකොට magnet එක stable වෙන්නේ උතුරට සහ දකුණට මේක යොමු වෙලා. චුම්බක උතුර චුම්බක දකුණ ඒ දෙකට මේක මේ වෙලාව තමයි stable වෙන්නේ. එතකොට ඒ අර අපේ පෘථිවියේ තියෙන මේක තියෙනවනේ. In the earth also there's a magnetic field now. You can discover that magnetic field and also the like directions to that. Okay, this experiment is not to do that, actually to test the properties of these things. What do you think? So what about iron nail? Will it attach or detach? Iron nail, what will happen when iron nail is closer to a magnet?
Attach?
Yeah, it will attach. So coins, I said that some coins are attaching, some are not. Brass nail, brass nail.
Attach?
Or detach. A pebble. Okay, so please test that. So this is a very simple thing that you can do, right? Pebble, plastic ruler, those are not, right? So then mainly metals will attract, mainly. But some metals are not. Not all the metals. Some are, but some are not. Right? Then plastic ruler, you can say does not attract. So similarly, do the practical and try to fill this chart as a homework this week, right? This week homework, please try to fill this chart using this permanent magnet. If you cannot find permanent magnet, I advise you. So one easy thing that you can do is today you can order using Daras, right? Online order can be placed. Even you can place, or with the help of your mom, you can place the order and you can get one within few days, right? So that is the easiest way, because like it is not. I think you can find one easily, because I think your mother is also working in related field, so you can find it easily, right? Okay. Certain materials will attract, but certain are not. Materials which attract towards magnets are known as magnetic materials, right? Iron, nickel, chromium, alloy, right? These are magnetic materials, right? So alloy ferric is used to make magnetic, like powerful magnets. So there are powerful magnets and there are some. So these magnets are not that powerful, right? But these magnets are made with ferrite. So when it is made with iron ferrite, so it is basically, these magnets are really, really powerful. But it can, so, but these magnets are not, these magnets, if you have these magnets, you can see it attract, but the thing is, it's not that much powerful. And inside the hard disk also, there is a magnet. Inside the hard disk also, there is a powerful magnet. So very powerful magnet, it's inside the hard disk. Okay, poles, North Pole and South Pole, I said about this, right? So when you stabilize the magnet using the thread, the North Pole direct to the north and South Pole direct to the south. So that is how. So I think you have done the pole marking in magnet in lower grades, right? How to mark poles in the magnet in your maybe grade 7. You have done that practical, how to mark the pole, how to identify the south and north.
Yes.
Okay, so here this activity, so so since I didn't think to start this chapter, I was thinking to discuss the questions and finish it, but so as an introduction only, I'm doing this part. Next day I'll be giving you the presentation and the note on this, right? So this, a bar magnet, iron fillings, thin polythene sheet or polythene bag, sheet of paper, that is what you need. So what you need to do is cover the bar magnet complete with the polythene bag. So why it is necessary? Because you are going to test the, like you are going to attract things, therefore it's better to cover. But even though you cover this using polythene bag, the magnetism remains, right? Don't worry, the magnetism will not be, it will be reduced a little, but the thing is it will be there. Then heap the iron fillings on sheet of paper, right? So dip the magnet into heap of iron fillings. So then you can see this kind of, take the magnet out of the heap iron filling and observe the pattern of iron fillings that attract the magnet. You can see these are the pattern like hair. Actually, you can do this with sand also. Have you done this practical with sand? But you have to,
Yes, sir.
sorry?
Yes, sir.
කරලා තියෙනවද සෑන්ඩ් කියන්නේ මේක අර මැග්නට් එක අරගෙන කොලයක් වගේ ඔතන්න ඕන මේක වටේට නැත්තම් මේ අර ඒ වැලි ගෑවුනාම හරි කරදරයි අයින් කරගන්න ඊට පස්සේ ඔයාලට පුළුවන් පුතේ මේ නිකන් මේක අපි කොලයකින් හොඳට ඔතලමුකෝ ඔතලා so you have to wrap this using a paper ඊට පස්සේ වැලි වල ටිකක් පොඩක් එහාට මෙහාට අරගෙන යන්න අතුල්ලගෙන what will happen what is the observation if you have done this with sand so what is the observation
It will attach.
so what sand will it attach
No,
sand වැලි ඇදිලෙනවද වැලි ඔක්කොම ඇලෙනවද මේකට
no, sir.
then which will attract මොනවද attract වෙන්නේ මොන yes there are magnetic materials in sand right there are magnetic materials in sand right these magnetic materials මේවා මේ අයන්ම නෙවෙයි හරිද හැබැයි අයන් උත් නැත්තේ නෑ හැබැයි මේ වැලි වල තියෙනවා මේ magnetic materials these magnetic materials will attract then you can after collecting these magnetic materials you can do the same practical and then you can see these magnetic materials arranged like so it's arranging from south to north pole to south pole so you can see these iron fillings are thickly attached and can be easily identified magnetic power is concerned in these regions so mostly this concentrated power is there in the north pole and the south pole දැන් මේ මැද්දට වැඩි ඇලෙන්නේ නැහැ මේ north pole එකේ south pole එකේ තමයි උඩරිම ඒකට මේ අග්‍ර දෙකේ උතුර සහ දක්ෂිණ අග්‍රේ දැන් උත්තරේ north pole එකේ දකුණේ driver කියලා කියන්න පුළුවන් ඒ දෙකේ තමයි උඩරිම magnetism එක තියෙන්නේ එතකොට දැන් මේ තියෙන්නේ so this is these are different magnets so how the south pole and north pole located in each so this is U shaped magnet so south pole and north pole are there in the end and south and north in this this ferrite magnet so that is in both sides right so this surface and this south surface is this north so it can be and if it is a coin like thing then both sides south and okay pole marking so identifying a pole a magnet without the pole and how to mark magnet with poles you can see this this is the practical I said this I think this practical is there I saw this in scholarship book or somewhere that is why I said that they have you completed this in the lower grades anyway so with this point Puthe, I will stop for today right I need to discuss this but the thing is like I have small time concern because I have to start another class by 9:30 that is the concern therefore I'll be stopping here and next day I'll be discussing pole marking and also the magnetic fields and different practicals and electromagnetic part also I'll be discussing let's see whether we can put the class little earlier so actually I was putting the class due to like this Tisani's request because she can only join after 8:30 that is why I just put this into 8:30 but I'll check with her whether she can join early or if she's not willing to do so let's see what can be done so because if I can put this little early then I can finish it little early too okay let's do these practicals and this chapter I think this is a very short chapter but there are some practicals to do so with that it will take at least 2 days to finish this chapter okay I'll be covering that within next 2 days and then we can move to the new chapter actually magnetics so this magnet part is very important because we can do a lot of experiments with the magnets okay Then I'll stop from here. Good night. See you next day, right?
Good night, sir. Thank you, sir.
Welcome.